Hi, everybody. My name is Deba Chatterjee. I work as a senior product manager at Uber. I will briefly talk about anomaly detection and how it is useful in today's business world. And I basically provide you a context how anomaly detection works, and with an example on how Uber uses anomaly detection in sort of detecting outliers in its infrastructure, and then basically hand it over to someone who will go over and talk to you how all this is accomplished. So in the next slide, um, what you know what we will see is what is an anomaly. Anomaly is basically, you can consider it to be a thoughtful process of determining what is normal and what is not. And the anomaly detection itself is a technique used to identify unusual patterns, and that does not conform to an expected behavior. There can be a point anomaly, there may be a contextual anomaly, and there can be a collective anomaly. Now, in this particular, in the presentation, I will mainly focus on the contextual anomaly. But in general, in today's world, anomaly detection is playing a huge role in many areas of business. You can see how fraud detection in credit cards is something. It's an anomaly detection. Health monitoring system in hospitals. Yes, if you have a huge number of patients, or even for a single patient, how do you track if the patient is improving or there is deterioration in the health? Network intrusion, sudden, if there is a unusual pattern, suddenly you see a huge bunch of or packets of data being copied from one machine to the other. Is it normal? Those type of things are being tracked, and those are some practical applications of anomaly detection in the business. There are other areas as well. I mean, the implication of anomaly, or the application of anomaly detection in the business is spreading, and we see more and more use of anomaly detection in various industries. Now, in the next slide, what I will do is I will talk about how anomaly detection itself is used at Uber. Uber has a system called Argos, which is used to detect, which was basically the foundation of the Uber observability platform. So it basically collects data from various utilization across many servers, hundreds of thousands of servers, and basically it aimed at uh, reducing engineer fatigue, because what happened is that using static thresholds led to lot of alerts coming every now and then, because static thresholds are not intelligent. They doesn't know whether this is a normal situation or it's an abnormal situation. So given my past experience, I have also seen that setting up the static thresholds often leads to false negatives, like, okay, the usage was low, but that low usage was not normal, so the alert never happened and we had an outage. Or false positives. There was alarms raised and alerts sent out, and the engineer looked at the alert 3 a.m. in the night, and then saw, okay, this was normal, and they had to close it, and then it was very difficult to 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 sort of fix that bad experience. So often anomalies are contextual. So when Uber looked at this problem, you can see on the left hand side of this slide, there is a chart which shows the blue bar is basically patterns of usage at the time of thunderstorms. So when there are local thunderstorms in Chicago, people tend to call more Uber. Now, would you say it's an abnormal situation? No, it's a normal situation. What the system analyzes is that the definition of normal in a certain context. So Saturday evenings, concerts, sporting events, or even this type of weather pattern they actually dictate usage. It's not that we should be using the past usage, which is the orange line here, to actually determine whether it is normal or abnormal. So the main takeaway from this is that today's normal and tomorrow's normal are very contextual. They don't depend on each other. So with that in mind, in the next slide, what I can we basically see how to make fast decisions, and or rather the need to take fast decisions. So the need was to decide whether a data point is indicative of an outage in less time than the arrival of the next successive data point. So how do you detect and how do you determine that this data point alone is an indicator of an outage, and not wait for the next data point to come, because it might be too late. So so the whole goal of this system was to achieve a low evaluation time while maintaining very high actionability. So we created this system. This is very actionable. So it issues alerts if there is a degradation in system performance, but at the same time sort of minimizes engineer fatigue. So think about being two goals were set. One was to accuracy of alerting, as well as minimization of alerts. So the system consisted of basically two systems. One is the parts. One is the outlier detector, which actually was looking at this continuous stream of data, and then reading those data points and applying different machine learning algorithms models. It actually detected what were the outages, and once the outages detector test it sort of indicated that there is an outage, it would actually send out an alert or an email to the concerned engineer. So this was the foundations of the observability system. And when the system was built, there were certain attributes that we think should be attributes of any good anomaly detection system. So in the next slide, we will see that what are the attributes of an anomaly detection system. So the biggest thing that I think an anomaly detection system should have is the ability to provide an answer, always return an answer that is as good as yes or no. Is it an outage or is it not an outage? It should have a ready answer, and it should be very accurate. The bigger, more important thing, like I mentioned before, should not be biased based on the past event. It is not something that can rely on what has happened in the past. Think about even although maybe a little bit outside of this context, but you cannot use the past stock price as an indicator of future. So something very similar. It's not necessarily, even though often we could say that okay, and high CPU usage is an indicator of an anomaly, but not high CPU usage with respect to what. That context has to be set. Be dynamic and self-learning, so that it can learn from its own feedback mechanism. So that is continuously evolve the model. Should not miss anything. So it should be very robust, so that it can be able to read the continuous stream of data that is coming from various sources, and has the ability to be selective, as well as, I mean, this is the ability, the accuracy of the observability system that determines how good it is, how, whether when it sends out 10 alerts, 9 must be accurate, or even more, 1,000 alerts, 999 must be accurate. That is the that determines the accuracy or the success of an observability system. So with that said, I will now hand it over to Suman, who will go talk more about anomaly detection in general. Thank you.